Continuing on with Chapter 16. One of the big problems we have in the ocean right now is pollution. There are several kinds of pollution that we have in the ocean. This is on page 480. Sewage is type of pollution, trash just in general, oil, industrial chemicals, fishing gear. Those are all kinds of pollution. The trash debris, like the fishing gear or any trash, can kill a lot of marine mammals. And they can get entangled in old fishing nets. They can ingest or eat trash, and it kills a lot. Make sure you know this graph. Now, one thing about this graph to notice is that most of the oil in the ocean is not from spills. We always hear about the spills in the news, the Exxon Valdez, the BP oil spill, but actually most are just natural seeps. If you've ever been to Carpinteria Beach, there's oil that seeps out of the ground and gets on your feet and turns into tar and is annoying, but that's a natural seep. And again, most of the oil in the ocean is there naturally. So here's a picture of an oil tanker that has spilled fuel. The largest spill of oil was the Exxon Valdez, which happened in Alaska in 1989, until the Deepwater Horizon, which was the Gulf of Mexico a couple of years ago. What happened was this oil tanker was a boat, and it ran into the ground, and the hole ripped open, and it spilled millions of gallons of oil and totally decimated the Alaskan coast. Well, Congress acted, and they passed the U.S. Oil Pollution Act of 1990, which requires oil tankers to have double hulls by 2015. The oil industry has really pushed Congress to extend the deadlines, and really just a few of our oil tankers have double hulls now. The industry has fought and fought and fought this law, and they have been successfully fighting it. And they're not double hulled, even though it's only now, a couple of years until their deadline. They've been fighting for extensions. So the BP Deepwater Horizon is not in your book; it's too new. But let's talk about it. So it was an explosion on a oil rig that drilled into the ocean in the middle of the Gulf of Mexico. And the oil flowed unabated, unstopped for 3 months. The explosion killed 11 men, and 4.9 million barrels of oil were released into the Gulf of Mexico, and that was really, really bad. Some ways to clean up oil spills: booms, skimmer boats, genetically modified bacteria, chemical dispersant. You have some handouts, so please, when you're studying for this and for this, where you have a lab, you have handouts, so please make sure you study those when you're studying about oil spills. Very important. Some other problems in the ocean is, again, eutrophication. We've talked about many times, from excess sewage or fertilizer runoff. You can also have other kinds of harmful algal blooms. For example, a red tide is when dinoflagellates, now this is a phytoplankton, produce a toxin that kills birds, fish, mammals, and humans. And the dinoflagellates down here in this picture make the ocean look red. That's not blood. They call it a red tide because it's too many of these guys that look red, the dinoflagellates. And they're toxic. So what happens is that you have excess nutrients that run off of fertilizer or a sewage dump or something. And this dinoflagellate now has a ton of nutrients to start reproducing, like nitrates, phosphates. And they make so many of themselves, and they're toxic, that the fish will get infested, and the birds that eat the fish, or mammals that eat the fish, or humans that eat the fish can get poisoned from the dinoflagellates. So when there is a red tide problem, they will have a warning and tell people not to eat fish caught during this time because it is a red tide, and it is dangerous. 482. We're talking about overfishing. So in the next 20 years, 90% of fish will be eliminated from the ocean due to overfishing. Now, in the United States, we've got chicken and beef and pork and other kinds of protein sources, but a lot of Asian countries, and you're talking billions of people, rely on fish for their protein, and so this becomes a food security issue. Where are these people going to get protein without fish in the ocean? They may become malnourished. Turn the page to 484. Make sure you know this graph and caption which talks about the New England cod fisheries. New England cod was extremely important and extremely profitable, and then we had new technologies that caused so much more to be caught that it was unsustainable, and then the population crashed. That's an extremely important example of overfishing, one that could potentially be on an AP test. Very important, very famous. Fishing technology, well, first thing what happens, and now the new technologies are like sonar mapping, satellite navigations, thermal sensing systems. These kinds of things let fishermen know exactly where the fish are. Well, if they know exactly where the fish are, they're going to catch more. And it ends to population crashes. It leads to population crashes. So first you have higher catches, like right here. They had lots of catch of the cod. And then the population crashes because there's not enough left to make babies to repopulate. There's 3 types of fishing techniques here that also lead to overfishing. You have drift nets, long lining, and bottom trawling. Drift nets tend to catch species like dolphins and drown them. Long lining also has a lot of bycatch. So bycatch is catching a species that you don't mean to catch. Long lining is for things like swordfish, but it also can catch sharks and things, which are extremely important top predators in the ocean. And then bottom trawling is extremely bad. It's for getting shrimp off the bottom of the ocean, but 90% of bottom trawling is bycatch, things that aren't shrimp, and they have to throw it back, and most of the time they're dead. It also, when you're scraping the bottom here, it's called a benthic community. When you scrape the bottom, you're also ruining the habitat for things like brittle stars and sea stars and urchins and things like that that live on the bottom. Page 486. Make sure you know that China catches the most fish in the world. On page 487, know the definition of maximum sustainable yield, which is the number of fish that can be caught and still leave enough fish to reproduce for next year's catch. So how do they do this? Now, Alaska has great sustainability in their fishing. They have quotas per boat. Your boat can only catch 20,000 pounds of crab this year, so we leave enough for next year. Fishing licenses. If you go to Castaic Lake, you have to get a license to fish. In a lot of places, you have to throw back the females, so they're the ones who reproduce and make the babies. Now, you need males too, but you can leave a few males that can actually fertilize a lot of females, crabs and fish and things. You also have size limits. You have to get ones that are bigger rather than smaller. 488. Marine reserves are areas that we call no-take areas. You cannot fish or harvest from these reserves. They preserve the marine ecosystem and act as a nursery for fish, so fish stocks outside the preserve can increase. When these were first started, maybe a decade and a half ago, they were vehemently opposed by fishermen. They thought, you cannot take away some of our areas to fish in. This is not fair. And what they found was, over time, the fishermen noticed that the fish actually increased outside the reserve. So the reserve was actually a protected area that the fish made more babies. And in essence, the fishermen then went, oh, these are really good things. Let's protect marine reserves because they actually increase our number of fish overall. All right, and the page here, page 492, the last sticky note for this chapter, talks about the benefits of small, medium, and large reserves, and it's basically saying medium-sized reserves are best because they allow enough space for to provide space for fish to reproduce and grow into adult size, but then also the other stakeholder, which is fishermen, can then fish and make money and provide us with food. All right, that's the end of chapter 16.